Hi and welcome to John's Maths book. In this video, I'm going to be showing you how to evaluate the indefinite integral of cos⁴ Θ dθ. If you like the video, then please hit the like button, and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's look at how we find the indefinite integral of cos⁴ Θ dθ. To evaluate this, we need to manipulate the function using trig identities, and we'll use some integration by substitution to arrive at the final solution. So let's facilitate this process by splitting the function into two parts. Cos⁴ Θ is equivalent to cos² θ multiplied by cos² θ. We can now use the double-angled trig identity of the cosine function to replace cos² θ. Using this trig identity, cos²Θ equals cos² θ minus sin² θ. Using another trig identity where sin² θ plus cos² θ is equal to 1, we can replace sin² θ. We can replace it with 1 minus cos² θ. So cos²Θ is now equal to cos² θ minus, and in brackets, 1 minus cos² θ. If we evaluate the bracket, we're left with cos²Θ is equal to 2 cos² θ minus 1. If we add 1 to both sides of the equation and divide both sides of the equation by 2, we're left with cos² θ is equal to 1/2 multiplied into the bracket of cos²Θ plus 1. So now, making the substitution for cos² θ, we're left with cos⁴ Θ is equal to 1/2 into the bracket of cos²Θ plus 1 multiplied by 1/2 into the bracket of cos²Θ plus 1. Expanding the brackets, we have cos⁴ Θ is equal to 1/4 times cos²2θ plus 1/2 times cos²Θ plus 1/4. We can now use the double-angled trig identity for the cosine function to substitute for cos²2θ. cos⁴ θ is equal to cos²2θ minus sin²2θ. Now, using the trig identity sin²2θ plus cos²2θ is equal to 1, we can substitute for sin²2θ. So we have cos⁴ θ is equal to cos²2θ minus, and in the bracket we have 1 minus cos²2θ, which is the substitution for sin²2θ. So expanding the bracket, we have cos⁴ θ is equal to 2 cos²2θ minus 1. If we add 1 to both sides of the equation and divide both sides of the equation by 2, we're left with cos²2θ is equal to 1/2 into the bracket of cos⁴ θ plus 1. Now, if we make the substitution for cos²2θ and multiply by 1/4, we're left with cos⁴ θ is equal to 1/8 multiplied by cos⁴ θ plus 1/8 plus 1/2 multiplied by cos²θ plus 1/4. It follows, therefore, that cos⁴ θ is equal to 3/8 plus 1/8 times cos⁴ θ plus 1/2 times cos²θ. Our original integral of cos⁴ Θ dθ has now been transformed into 3 separate integrals, which will be easier to manage. They are 3/8 multiplied by the integral dθ plus 1/8 multiplied by the integral of cos⁴ Θ dθ plus 1/2 multiplied by the integral of cos²Θ dθ. Let's now evaluate the integrals one by one. So starting with 3/8 multiplied by the integral of dθ, the antiderivative of dθ is theta, and multiplying that by 3/8, we get 3/8 θ plus a constant of integration. Let's call that C1. If we now look at evaluating 1/8 multiplied by the integral of cos⁴ Θ dθ, we can use U-Substitution to evaluate this. So first, let U equal 4θ. du by dθ is 4, and it follows that d theta is 1/4 du. So if we now make this substitution for 4 theta and d theta in our original integral, we have 1/32 multiplied by the integral of cos u du. The antiderivative of cos u is sine u, so we're left with 1/32 multiplied by sine u plus a constant of integration, let's call that c2. So substituting back in for u, which we know is 4 theta, we have 1/32 multiplied by sine 4 theta plus a constant of integration, let's call that c2. Let's now look at our third and final integral. So we have a half multiplied by the integral of cos²Θ dθ. So once again, we're going to be using U-Substitution to evaluate this. So we can begin by letting u equal 2 theta. So du by dθ is 2, and it therefore follows that dθ is a half du. So now if we substitute in for 2 theta and dθ, we're left with 1/4 multiplied by the integral of cos u du. The antiderivative of cos u is sine u. So we have 1/4 multiplied by sine u plus a constant of integration, let's call that c3. Now substituting back in for u, which is 2 theta, we have 1/4 multiplied by sine 2 theta plus a constant of integration, c3. We now have our final answer, so the integral of cos⁴ theta dθ is equal to 3/8 multiplied by theta plus 1/32 multiplied by sine 4 theta plus 1/4 multiplied by sine of 2 theta plus a constant of integration.